hammer through some questions. I want to start with the homework 5 and then we'll proceed from there. Is that okay with you guys? Okay. Not that the review's not important. We hadn't had a chance to talk about anything from homework 5 yet, so let's start. John. Number 3? Sure. So the first thing that I'm going to do is I'm going to factor to see if there's any reducing that happened. So the denominator factors x plus 5 times x plus 3. We good there? The numerator does not factor because it's a sum of squares, not a difference. So there's no factoring that can be done in the numerator. And there's no factoring that can be done, there's no reducing to do. So we're all set there. So this, to find my vertical asymptotes, I take my 0. So if I apply zero product property, that really means each factor is set to 0. Vertical asymptotes at positive 5 and negative 3. Cool there. The x, I take the numerator and set it equal 0. But I can see real quick that that's just going to give me an imaginary result. So since I'm only going to get an imaginary solution to that. If you weren't sure, you can solve it, but I promise you it just gives you an imaginary result. Everybody's okay still? Okay. What else is on my intercept? Well, if I plug zeros in for x, I just get 9 over negative 15, which is negative 3/5 when I reduce. You could write that as a decimal also. Probably be more appropriate to write it as a decimal if we're about to graph this, but if I'm doing it in my head, it was it was a little bit easier to leave it as a fraction there, I guess. Still doing good? Okay, and then the last I need before I make are those horizontal or other asymptotes. In this problem, the degree of the numerator is 2, and the degree of the denominator is also 2. We're in that second situation where the degrees are equal. In that situation, I know I have a horizontal asymptote or end behavior at the leading coefficient of the numerator over the leading coefficient of the denominator. The leading coefficient in the numerator is 1, the leading coefficient in the denominator is 1, so that is 1 over 1. Yeah,
for the lowest common denominator, is that just the thing in front of the point of x?
So the leading coefficient, yes, okay, is the coefficient, the highest degree term. Okay. John, are you okay with that? Yep. Okay. So now we'll go ahead and make ourselves an XY table. 3 points, and then my first vertical asymptote, which would have been negative 3. And then 3 more points, and I'm going to need my second vertical asymptote of 5. Yeah.
Can you explain how you got negative 3/5 for the x terms?
I just put 0 in for x, which gives me 9 over negative 15.
Oh.
And then I reduced.
Yep.
No problem. Maddie?
For the table, if you wanted to, could you do like positive 5 as like a different table and do 3 lower than 5 and 3 higher than 5? Like by itself instead of putting it into all one table?
Assuming that, well, the issue there is that you end up with like some of the things that are lower than 5 being also lower than negative 3. Mm-hmm. Rather close together, that could happen, and then that's going to screw everything up. Okay. So it's really preferable that it all goes in one table because you can't really make that mistake. Okay. Like for example, if the two numbers were 3 and 5, if you did it that way, you're very likely to have picked less than 5. You picked 4, 3, 2, mm-hmm. which is a problem because, well, 3 is one of your other asymptotes, and 2 is on the other side of the other asymptote. So. Okay. Yeah. It just no, it's not wrong to do it that way, but you have to be really careful that you're the way you're picking your points. Does that make sense?
Yeah.
Okay. Everybody's good so far? John, you're still all right?
Yeah.
Okay. So less 3, I'm going to do -4, -5, and -6. Bigger than 5, I'm going to do 6, 7, and 8. And then between -3 and +5, I'm going to do +4. And then I'm going to pick something that's about halfway in between, which I think is 1. Right, that's 4 from each. So that's like halfway in between. Is that okay? So now all I have to do is find these y coordinates. So I'm going to use my, what's up? Of course. I'm going to use my calculator to do that because, well, the numbers are going to get kind of big. Okay, and I'm going to do this the cheapy way. Oops. Don't mind what I'm doing right now. I'm just having to reset the modes on my calculator because I was using it for another class. Okay. So I'm going to go to the y equals menu. I'm going to type in my function. So I have x squared plus 9, and then divided by x squared. What is it? Is it minus 2x minus 15? Thank you. Trying to remember. Okay. And then I'm going to go to the table set option. So I'm going to press second in the window button. So the smallest value in the table I have is -6. So I want my table to also start. And the table in my graph goes up by 1. So I want my table to go up by 1s. Everybody good with that? And then I'm just going to press second and graph. And that's going to give me my table of values. So I can just kind of copy these in. 0.8. Notice I'm just rounding to the nearest tenth because if I'm graphing, I'm much more accurate than that. And then 1, a little bit to get to it. So I'm just going to scroll down. So -0.6, and then got to go scroll to 4. So that's -3. I got to scroll down to get to 6, 5, or 5, 6, and 7, or 6, 7, and 8. So that's 5, 2.9, and then 2.2. So far, so good. So now we're just going to do some plotting. Let's see. 1, 2, 3, 4, 5, 6. 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3, 4. Asymptotes, I have this horizontal asymptote or end behavior here at 1. I have a asymptote at -3. And then another one at +5. And then let's plot. So 6 and 1.4. -5 and 1.7. And then I have 6, 5, 7, 2.9, and 8, 2. So there's the other end of it. Is that okay? Alyssa?
For the x intercept, I'm confused. Are you supposed to set the whole thing x equals 0, or just like the numerator to 0 and solve out?
So if you've read already, if there's any reducing to do, you can just set the numerator equal to 0, and that's enough. If you didn't reduce, you'd need to set the whole thing equal to 0 because you might get an extraneous solution. But if you've gone and reduced already, that can't happen.
Okay. So what's the difference between like x-intercept and then y-intercept?
So an x-intercept, you're solving for the numerator equal to 0. And y-intercept, you're just plugging 0 in for x. Ms. Roth. Sure. Okay. So I'm just going to do that down here. So I will certainly do that. Do you guys want me to do the whole problem for number 5, or do you just care about the other asymptote? I know that that Amanda's just asking about that, but as long as I'm starting this, if I'm going to do it, like we can do the whole thing, or if you guys don't care about the whole thing, we can just do that one piece of it. That's fine too. You tell me. I've already done them. I know how to do them. I'll do whatever you guys want me to do. If you don't say anything, I'm just going to do the part that Amanda asked me about, and that's fine. I just want to double check. Yeah. Okay. That's fine. So the vertical asymptote, we just set the denominator equal to 0. Oh, I guess I didn't bother to really worry about factoring this because you can tell right away that it's not going to reduce. Everybody good with y? You can look at it right away and tell that. Of 2 that can't be, like, it's not a greatest common factor out. The numerator is going to have leading coefficients of 1 when we factor it, so there's no reducing that could happen. So I'm not going to really worry about that. So to solve the numerator, the y-intercept, when I plug 0 in for x, I basically just get 18 over 1. And then my last thing is my horizontal or other asymptotes. So here I notice that the leading coefficient is the degree of the numerator is 2, and the degree of the denominator is 1. In this situation, I'm going to have that slant or oblique asymptote. To find that, we have to do polynomial division. And since the divisor in this case, the leading coefficient isn't 1, we can't use synthetic division. We have to do long division. So that's what I'm going to do. So I'll just set this up as a long division problem. Everybody so far so good? Again, if you need me to slow down, let me know. So to do the polynomial division, I'm going to ask what times 2x gives me x squared? 1/2 x, right? 1/2 times 2 gives me 1, and x times x gives me x squared. Oops. Multiply that. And I subtract down. So x squared minus x squared is 0. 11x minus 1/2 an x is 10.5x. And then we bring 18 down. Amanda, you still doing okay? Okay. Then I'm going to ask myself, what times 2x gives me 10.5x? Would be like 5 1/4, right? 5.25 times 2 would give me 10.5. So I'm going to put 5.25 there. And again, multiply it to both pieces. Subtract down. And I'm looking of 12.75. Now the remainder I don't give two hoots about. That doesn't tell me anything. What I care about is the quotient. Because that's going to be my my slant asymptote. Notice here I've got rid of the fraction for the 1/2. I just wrote it as a decimal. If we're about to graph it, it just makes life a little bit more convenient to not have the fractions in there. You know what I mean? Everybody doing okay so far? All right. Time for our table. Maddie?
Can I go get my graphing calculator?
Sure.
I think I left it in my locker.
Yeah, no problem. So I have my negative 0.5, which is my vertical asymptote, as my middle. And now what I'm going to do here is I'm going to use the x-intercepts over here. I don't want to put them right next. I need to know whether the graph is like going up like this in between the x-intercepts or going down like that between the x-intercepts. But I'm basically just using them so that I can skip having to look up a bunch of extra points. And it tends to give me a really nice picture if I do incorporate them like I am doing here. Mackenzie?
I'm confused why you're using more than 2 because
Oh, so this, I'm not graphing the asymptote right now. This is the table for the function.
Okay.
But yes, when we get to that, I'm going to do that part next before I draw in the rest of it. But I'm finding points right now before the asymptote. So, but what you're asking is correct. I'm just not doing that right now. And then in between those is like -3.5. I don't want to worry about a decimal here, so I'm just going to pick either -3 or -4. Or I'm sorry, that's not right. It's like 5.5. So I'm either pick -5 or -6. It doesn't really matter. I'm going to pick -5. Okay there? Now, from experience, I know to get the opposite side of this to turn out really nicely, I'm going to pick my values so that they're kind of symmetric. So you see how the distance between these 2 points is like -1.5? I'm going to do the same thing here. So I'm going to pick +1 there, which is like 1.5 away. Between -5 and -2 is 3 away, so I'm going to pick that to be 4. And between -5 and 9 is 4 away, so I'll pick that last one to be 8. This is going to just end up giving me a nice picture that'll be a little bit easier to piece together if I do that symmetrically. So far, so good. Okay. To get the rest of these values, I'm going to use my calculator. So it was, what do we have? We had x² plus 11x plus 18 divided by 2x plus 1. And then we'll reset our window. I want my table to start at, I don't really need the -9 because it's already in my table. I already have the y value for that. So I'm just going to start at -5. I mean, you could go all the way down to -9 if you wanted to, but like we already know the answer there. So that's 1.3. And then at positive 1, we're 10. And we're going to, I'm going to scroll down to get to 4, which is 8.7-ish. And then scroll down to get to 8, which will be 10. And then as Mackenzie pointed out, we're also going to need an XY table for this fella. So what I tend to like to do, I think I end up getting the best picture if I pick my x's so that they're kind of far apart. If I pick them right next to each other, if I make a little bit of error, it makes a lot of error with my line. So I'm going to pick them kind of far apart. But I know I'm covering up through -9 to 8 already on my xy axis. So I just picked -8 to +8 because, well, I'm multiplying by a half anyway, so it just kind of knocks down some of the decimals that I have to worry about. Is everybody okay there? It doesn't really matter the points you're using, but that I just wanted to explain to you why I chose those, because it's not like for no reason. It's just maybe not an awesome reason. It's just like a reason. So what I did then, I'm just basically plugging in. So 0.5 times 8 plus 5.25 is 9 1/4. And then, oops, put that in the wrong spot though, huh? 9 1/4. And then doing the same thing with -8. Is positive 1 1/4. So far, so good. Again, if I'm doing anything you don't like or you want to get some more feedback about or you just want to ask about, like holler at me. Certainly talk about it. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I don't think we did any negative points in there, no. So I'm not going to bother with any negatives. So I have -1/2. I have -8 and 1.25, and then +8 and 9.25. So I got like, oops, there for my asymptote. Everybody good with that? All right, I'm going to plot my points. So here is -9, 0. And I have -5 and 1.3. And then I have -2, 0. So I'll draw that piece. Everybody okay there? Then I'll do the next one here. So I have 1 and 10, 4 and 8.7, and then +8 and 10. So I'll draw that section. So I got something that looks a little like that. And again, if you graph these on your calculator and take a look, you'll see that the graph should match this pretty closely. And certainly you'll be able to do that on the test. Use your calculator to kind of check things. That's totally fine. The expectation though is you'd be able to also show me how you're finding these little parts. I'll certainly ask for each of those as well on the test. You should be able to do those and at least show enough work by hand to justify kind of how you're getting those. Is that okay with you guys? But the picture you shouldn't have, like, you can use your calculator to double check to make sure that the picture you're pulling is a good one. So far, so good? Amanda, was that what you needed? I know that was a lot more than you needed, but I got the part you needed also, I hope. Good. Yeah, hold on. Kaylee, right? Oh, good.
Can you go over what you chose?
Yeah, so I used -9 and -2 because those were my x-intercepts. And I certainly need a point in between them because if I have those at 0, I need to know, like, is the graph doing this or is it doing that? So I picked something that was about halfway between them. And then, because I've done problems like this a bunch of times, inherently we kind of always end up picking our points to be symmetric, where like one half of our table kind of looks like the other half of our table. So like the distance between these points is like 1.5 units. So I picked that point so that it was also 1.5 units. The distance here was 3, so I picked this distance to be 3. And this distance was 4, so I picked that distance to be 4. That's kind of what I was doing in my head. Would it have still worked out if you used different points? Yeah, probably, but it might have been a little more ambiguous as to like getting that curve in the right place. When you have both x-intercepts on one side of your asymptote, doing what I've done here is often going to be quite helpful. If the x-intercepts were on either side of your vertical asymptote, I don't think you'd have to be nearly as careful. Does that help also? So just because I had both x-intercepts on one side, I thought, is why I kind of did it this way. And probably if you did this naively and just did like -1, -2, -3, and then like 0, 1, 2, and tried to graph it, it might have been pretty ambiguous, like what to do with how to complete the graph, where mine, it was, at that point, was pretty obvious and like how it was curving and getting the curve right. But like without having done some of these or run into that, I don't know that it's reasonable that you would think to do that. Does that help, Kaylee? Okay. Edmund?
So can you explain how you got the
Yeah, man. So I plug 0 in for x, so I have 0 plus 0 plus 18 over 0 plus 1. It's okay. No problem.
And also, for number 3,
Uh-huh.
I got a discontinuity because x plus 3 and x plus 3.
But this doesn't factor because it's not a difference of two squares, it's a sum. So that one doesn't factor. I think there was one of these that has a discontinuity though, wasn't there? Or no? Was there one? Do you guys remember? Oh, maybe there wasn't one. Was I that dumb and didn't put one on here? Ugh, sure looks like it is, huh? Well, what else is new? Mr. Kulik screws up again. Mackenzie.
So for number 4, for the other part,
Sure. So the degree of the numerator is 1. The degree of the denominator is 2. Since the degree of the numerator is less than the degree of the denominator, we're going to either have a horizontal asymptote or end behavior at y equals 0. It's always 0 if the degree of the numerator is less than the denominator. In this case, I can actually tell that it's an end behavior rather than an asymptote because I have an x-intercept. So there is a point where the graph crosses y equals 0. So really, technically speaking, I know that's an end behavior. I wouldn't need you to be that picky on your test, but I figure I'd mention that I know that it's an end behavior here. Yes, in that case where the degree of the numerator is less than the degree of the denominator, it's always y equals 0. Yeah, and I'm not even really going to be that picky that you guys do that, but you could. Yeah. Does that feel okay? Everybody else? It's okay? So in comparison, if we look at number 1, again, that's a situation where the degree of the numerator is 0 and the degree of the denominator is 2. So it's again going to be y equals 0. And this time I know it's a horizontal asymptote as opposed to an end behavior because the numerator has no solutions to it. So that will never cross. But really, this situation is the only one you can just jump straight to the asymptote versus end behavior. The other ones, it's never that clear until you start graphing things. Alyssa.
Can you just reiterate what to do when you have like a restriction? I forgot the name of it, but like how does that apply to the chart and then the graph?
Yeah, so let's just look at a quick example. Let's do yeah, that should be okay. No. That's not the way I want that. Hold on a second. Let's do that. And let's actually do that. Okay. All right. Sorry about that. I just needed a minute to make sure this was going to do what I wanted it to. Okay, so I'd start by factoring. The numerator, easy to factor, right? Multiplies to 2, adds to give 3, that's 2 and 1. Good with that? Denominator, we'll factor that by grouping. So from the first group, I can take out an x squared. From the second group, I can take out a -1. So that gives me x plus 2 times x squared minus 1. And then the x plus 2. And then x squared minus 1 factors to x minus 1x plus 1. And I can do some reducing. So I have 1 over x minus 1, where x cannot equal -2 or -1. So far, so good, Alyssa?
Yep.
Okay. So these guys are restrictions or removable discontinuities if we're graphing. The nice part here is this is just a simple rational function. So I'm just going to treat it as such. This actually reduced more than I was planning on it too because I'm a dope. And I tried that hard to get this to work out and then I still screwed it up. But that's whatever. So here the vertical asymptote is x equals 1 and the horizontal asymptote is y equals 0. You could also use your rules for general rational functions and come up with the same thing though, right? The degree of the numerator is 0, the degree of the denominator is 1, so it's y equals 0. And set the denominator equal to 0 and solve, you get 1. Still the same thing. There's no x-intercepts, right? Because you set the numerator equal to 0, you get nothing, or no solution. The y-intercept is just -1, right? When I plug 0 in for x, I get 1 over -1. So let's make our table. So 1, 2, 3, and then I have my vertical asymptote. So my value is less than, I'm going to do 0, -1, -2. I'm going to point out to myself, though, that those guys are my removable discontinuities to remind myself when I draw my graph to make sure I use an open circle there instead of like a filled in one. And then those will be 2, 3. And now to get the y coordinates, I'll just plug the x's back in like I have. So 0 we already did. We know that's -1. If I plug -1 in, I get -1/2. If I plug -2 in, I get -1/3. If I plug +2 in, I get a +1. If I plug +3 in, I get +1/2. If I plug +4 in, I get +1/3. So far, so good? Bless you. You're welcome. All right, so let's see. 1, 2, 1, 2, 3, 4. And I'm going to go by like halves or something. So I have my vertical asymptote. I have my horizontal asymptote. I'm going to plot my points. So -2 and -1/3. Make sure I use an open circle. -1 and -1/2. Make sure I open circle. 0, -1, close circle. So there's that side. And then 2, 1, 3, and 4/3. So there's that end. So the only thing that you have to remember, Alyssa, is if those removable discontinuities weren't actually in your table, you'd still need to find that point and make sure there's the open circle there. Even if it didn't end up as a point in your table, you just add an additional point at the end for the RD or whatever and just make sure it goes in the right spot. But it's really no big deal. Like, the trick is making sure you catch them in the beginning when you do the reducing. But like how you deal with them in your table, it's not really a big deal. You can kind of, if they don't make up in your table, you can either choose them to definitely be in there, or you can just pick the points you normally would and be like, oh yeah, also need this one. Either way is fine. Kales.
Just making sure that when you're finding a restriction, it's always like the opposite, like cross out positive gives the restriction.
Yeah, the thing you're crossing out, you're setting equal to 0 and solving. So like if it was, the only place where I'd want to caution you is if there's a coefficient. So if it was like you crossed out a 2x plus 3, the restriction would be -3/2. Because you still have to worry about the coefficient part. But for the most part, that we've just had like monic terms that we've been crossing out where the leading coefficient's 1 and the degree is 1. But you could have weird things as restrictions. We haven't really seen that. I wouldn't give that to you on the test. But you asked me like a general question. I want to make sure I'm not giving too specific of an answer. Although the specific answer is what you're looking for. Edmund.
Can you show how we can use like synthetic division to find out?
Sure. So let's say that you had this one. So check to see if you can reduce. And we can't, right? So that's the first thing. You should check to make sure. Since you can't, and this is monic, we can really do our synthetic division. So I can make -2 divides 1 for -1, or -5, excuse me. And then just grind through the synthetic division like we would have before. So remainder constant x. So my slant asymptote is y equals 1x plus 2.
And if the x was like a 4, you got 4x.
Yeah. Yep. Exactly. Yes, Emily. So the divisor has to have degree 1 and leading coefficient 1. So I saw we had to do this earlier in the homework on this one, and we couldn't do the synthetic division because the leading coefficient wasn't 1. So that was the hang up there. Cool? Yeah, no problem. Again, like a lot of detail involved in this, so like a lot of sub-skills that we dealt with previously that are coming back. So again, if you need a minute to clarify or go over these things again or retouch a concept, like that's totally okay. That's why we're taking the time to do them. Right? Okay. Do we feel okay on homework 5 here? We kind of beat this one up pretty good, right? Should we talk about the review for a few minutes? Do you want to do that now? Like Maddie had asked earlier, I do have at the end of class, I had finished making it over lunch or whatever and got it scanned in. So it's not like I just haven't gotten it dropped in. But it's made. I just haven't dropped it into the content library, sync it and everything. So you guys can take a look. I tried to be super careful and go through it, but I probably still made mistakes because, I pulled a Kulik. Time with this, a lot of time in some of our cases. So let's out or didn't know what to do with, or feel like, boy, I think I made that a lot harder than I needed to. Sienna? 21? Sure. That's this one. So this one's, the synthetic division can be, or the polynomial division can be kind of a pain, right? All right. So the vertical denominator equal to 0, and we get x equals 2. The other asymptote situation, we got to do that long division. Since the leading coefficient in the divisor isn't 1, I'm going to do that. Notice that I put the 0x term in there because I had no x term, so everything will line up nicely. Remember doing that? Okay. So I ask myself, what times 4x gives me x squared? Well, 1/4 times 4 gives me 1. And then x times x will give me x squared. So when I distribute that through, I get x squared minus 2x. And then I subtract down. Sienna, you happy still?
Yeah.
Okay. X squared minus x squared is 0. 0 minus negative 2x is positive 2x. And I'll bring that -1 down. And again, repeat. So what times 4x gives me 2x? Well, that would be a half. And I distribute things through. That's going to give me 2x minus 4. I subtract down, and that gives me a remainder 3. So I have a slant asymptote at y equals 0.25x plus 0.5. Again, I just converted those fractions to decimals because if we're going to graph this, it's just a little bit more convenient to deal with decimals and fractions, right? Does that feel okay, Sienna? Okay. For the x-intercept, I'm just going to take the numerator equal to 0. I notice that numerator factors. So my solutions are -1 and +1. And my y-intercept, if I plug 0 in, I get -1 over -8, which is positive 0.125. So here I didn't use the whole table since I had just the one vertical asymptote. I didn't bother with it, but you could have if you really wanted to use all the points. It wouldn't hurt nothing. Still doing okay, everybody? Sienna? Okay. If I can go in too fast or I do something you're not sure about, tell me to slow down or stop or hold on or whatevers. I guess it's worth pointing out I didn't bother at the beginning to check to make sure there's no reducing I could do. I mean, I did do it when I did the problem, so I already knew there's no reducing to do. So I guess I kind of breezed right past that, and I should have at least made a cursory inspection to make sure there was no reducing. But make sure you do that because on occasion you can find some reducing to do. And I don't really need to worry about anything before 3, so I'm just going to go ahead and start my table at 3 to get those last 3 values. And you could certainly plug those into your calculator manually if you wanted to. You don't have to go through all the rigmarole of using that table on your calculator, but can if you want to. And then I need another XY table for my other fellow here. I'm going to use -4 and +4. So if I did -4, that's going to give me -1 plus 1/2, which is -1/2. If I did +4, that's going to give me +1 plus 1/2, so 1.5. Again, that's the slant asymptote there. And again, there's nothing magical about the -4 and +4 that I chose there. I just chose them because it was going to make the arithmetic kind of convenient. And they're relatively far apart, which helps get me, in my experience, because I'm not the neatest person in the world, I tend to get a little bit better picture if I pick them to be kind of far away. And then this is always really hard to get these things to line up when you're doing this on your tablet. All right. And then let's see, we have -1, 0, 0.25, and then 1, 0. It'll look like that. And then 3, 2, 4, 1.8, and then 5, 2. So it'll look kind of like that. And there we go. Is that okay, Sienna?
Yeah.
Yeah, no problem.
Cool.
Yeah.
How do you determine if it's going to be like a slant? Is it?
The degree of the numerator is greater than the degree of the denominator.
Okay, yeah, I'll just make it.
Yep. That's okay. Again, that's why we're asking questions. Again, we have a lot of stuff going on all at once. Big Mac. 13? Certainly. All right, let's hit up 13. Graphs. All right, so this is a solving problem. First thing I'm going to notice that is a proportion. So I'm going to solve this by clearing fractions. The first thing I'm going to do then is to factor any denominators that I can. The only denominator I can factor is that first one by taking out a greatest common factor of x. So if I look at the least common denominator of all fractions, I see distinct factors of 2, of x, and x minus 3. Is that okay, Mackenzie? And if I look at each fraction, none of those factors occur more than one time in any fraction. So that's my least common denominator. I don't need more than one of any of those factors. Is that okay?
What would you do if it was one?
Well, I just have like, if this was that, then I would have like x minus 3 squared. I just need more of them.
If the one, like, if there was x minus 3, only one, like one on the left, let's say x minus 3 is twice on the right one, left only had one, would you multiply another x minus 3?
You just have, it's the maximum number of times it occurs in a single fraction. So if one of them had 2 and the other one had 1, 2. It's just the maximum, it's not the total. Is that cool?
Yep.
Okay. So I'll multiply each side by the least common denominator. So I have 2x times x minus 3 over 1 times the first fraction. And then the least common denominator times the second fraction. And then the least common denominator times the third fraction. Mackenzie, are we still doing good? Okay. I'm going to go ahead and try to reduce. So the x can reduce, the x minus 3 reduce. So I'm left with 2 times 2. The 2x's reduce. So I'm left with x minus 3 times x plus 3. And then the x minus 3's reduce, so I have 2x times x plus 1. So far, so good? Now I'm going to multiply everything out, move everything onto one side, and try to solve my quadratic. So 2 times 2 is 4. X minus 3 times x plus 3 is x squared minus 9. And 2x times x plus 1 is 2x squared plus 2x. Move everything onto one side. So I have, when I subtract the x squared over, I just get 2x squared minus 1x squared, which is 2x, or is just x squared. The 2x is by itself. I add the 9 over, then subtract the 4 over. It gives me 5. What I'm left with is a quadratic equation. To solve a quadratic equation, I can either solve directly, factor, or use the quadratic formula. I can't solve this directly because I have both x squareds and x's in this equation. I can't factor it because there's not two numbers that multiply to give me 5 and add to give me 2. So I have to use the quadratic formula here. But we remember we can always use the quadratic formula. So if you wanted to skip trying anything else and just go straight to that one, that'll still work. So 2 squared is 4. 4 times 1 times 5 is 20. So 4 minus 20 is negative 16. The square root of a negative creates an imaginary number I, and then the square root of 16 is 4, so that's going to be 4i. And then since this has all a common denominator, it's all over one denominator, I can think of it as two separate things over two separate denominators and reduce each of them separately, which gives me -1 plus or minus 2i. Now I boxed that without checking, but I don't really need to worry about checking since the solution is imaginary anyways. An imaginary solution is not going to give us a zero denominator somewhere. So, but technically I should be checking to make sure I don't get a zero denominator before I box my solution. Mackenzie, are you happy with that?
Yep.
Did you get that anyways and you just thought it was weird that you got an imaginary solution?
No, I didn't.
Oh. Okay. Oh, yeah, with the 2. Yeah. So again, with the 2x there, it's tempting to want to treat that as one full thing. But really just remember it's still 2 times x, so you can just treat them separately like that. So you don't need the extra x rattling around in there, which makes life much harder when it comes to solving it. Alex.
How do you check for?
Yeah, so all I'm doing is I'm going back to the original and plugging my solution in for x and seeing if I get 0. So if I get 0 when I plug it back in, it's an extraneous. I just discard that solution.
Is your final answer?
Mm-hmm. Yeah. So like in this case, it didn't happen, right? But if my final answer had been 0 and 7 or something, let's say those were the 2 answers I got, 0 would be extraneous because when I plug it in either to the first fraction or second fraction, I get a 0 denominator. So I just cross that one out. But if I plug 7 in, that one's fine. So I would keep that one.
Would you just plug it in for x? Is that how you do it? Okay.
Yep, because the solution is a value for x, right?
Yeah.
Did that satisfy you, Jay? Sorry, I called you Alex at the beginning. I don't know. It's one of those days. Edmund.
So like, can you show how you find extraneous solutions with division problems?
Sure.
5. So can I just do like
Number 5, you said? Sure. That's fine. All right. So I'm going to go just straight to factoring and getting this thing all flipped around and everything. Is that okay? Okay. Since you're asking about something specific, I'm just going to scoot through the piece that should be pretty easy to do. Whether you can do it at the same speed that I'm doing it, that's not for me to say. Again, I've been doing this for so long that it's pretty easy. All right. So x plus 5s cancel. X plus 3s cancel. X plus 8s cancel. Let's just kind of keep a running tally here, I guess, of our restrictions before we get too far here. So I have -5, -3, -8. And I don't have to worry about any of those things because they're all coming from the non-division part, right? So that's not, I don't even have to think about that. Next thing, the x minus 6, which again is okay because the 6 is coming from here. If the 6 is 0, since it's being divided, it's still dividing by 0, right? So I would have positive 6. And then I can cross out the -7, or the x minus 7. And again, that would be the denominator of that fraction. So if I look at just that fraction, that would be something with a 0 denominator. So that one counts. And then I'm left with just x minus 8 and x minus 2. Is that okay? So again, more often than not, like the thing with the division is, like the x minus 7 or the x minus 6, it just, anything you cross out from something that's being divided really counts as a restriction. So like, let's just say we had something kind of trivial like x plus 3 over 1 divided by x plus 3 over 1. So this is clearly just going to be 1, right? But it still has the restriction that x cannot equal negative 3 because if x plus 3 is 0, or if x equals negative 3, I have this whole thing becomes 0, and then we're dividing by 0, even though it was in the numerator of the original thing. So that's the, it seems like it's trickier than it is, but it's really not a big deal. Does that help?
Yeah. So if something was like in the original numerator, then you would have that process.
Yeah, so if you have the thing that you're dividing, that fraction you're dividing, it doesn't matter where you cross out, it causes a restriction, whether it's numerator or denominator. Because if it's in the numerator, it means you have 0 over something, so you're dividing by 0. If it's in the denominator, that fraction has a 0 denominator, and that's a problem. Does that make sense? So the moral of the story is when you're, with the piece that's being divided, it doesn't matter if you're crossed out from the numerator, denominator, or after you flipped it, the numerator, denominator. It just doesn't matter where it crosses out. It still causes a restriction. Is that cool? So it's usually, there's no real trick to it. You just got to kind of remember that piece. What do you guys think? Does that feel all right? We still got, 10 or 15 minutes. If you got some more stuff, I'm happy to do some more. At this point, there's no sense in trying to do something else, right, with 10 or 15 minutes left. So we can bang away at some more questions if you guys have some more stuff that you want to talk about. I'm happy to do some more stuff. Amanda? Sure. Oh, yeah, just a few minutes. I was looking at the start time of last hour. That's my fault. Okay, so again, clearing fractions is going to be the technique I'm going to use. So I'm going to start by factoring the denominators. Here's the tricky thing that's going to make this problem much easier. Look at that second denominator. I'm going to take out a negative 1. So if I do that, the x becomes positive, the 1 becomes negative. And that makes such a huge difference because now I really just have 2 polynomial factors that are going to go in. And then even better, I can reduce that last fraction before I make my least common denominator, which makes life even better. So my least common denominator would just be this, which if you use that, everything works out pretty nicely at the end. If you included the 1 minus x in there, it gets pretty terrible pretty quickly. Is that what happened, Amanda? Yeah. So in the interest of having like 2 more minutes, I'm going to kind of pause here before getting into this big thing, because I don't even think I can finish writing the next step in 2 minutes. But that's the trick, is to make sure that you take that negative 1 out, and then life goes forward pretty nicely. Even if you had missed the 2, that's not the big deal. The negative 1 was the big deal. And again, I'll put the key up here before the end of the day so you guys can take a look at that. Before we go, test day Thursday, is that yay or nay? Nay. Okay, so we can be Tuesday, but we're going to do new chapter stuff on Thursday then. That's fine. That's okay? Okay. So we'll do it on Tuesday. I'll reset the calendar again.
I sent you an email regarding this thing.
Yes, I think I checked all that. Did you, I reply back to you today? Okay. What was your name again? Max. Yes. Did I fix it yet?
I didn't see it fixed yet.
Okay. Let's take a look at it. Yes, Jay. Are you waiting to talk to me?
On the test, like, will it be like identical to the review with the amount of questions, or how many?
Oh, it'll be less questions, but it'll be the same kinds of questions, the same format, like the same directions.
Okay, I was just making sure because that took me a while.
Yeah, no. That's a totally unreasonable number of questions for a test.
I'm sorry I didn't come to your community time. I had an NHS meeting.
That's okay.
So now that the test is Tuesday, when should I come in? Because I still have a couple questions.
Yeah, I mean, really, any day during community time this week should be okay.
Okay, I'll come in. Can I come in Thursday?
That should be okay.
Okay, thank you.
Yeah, you're welcome. If you think about it, send me an email on Thursday so I remember to look out for you.
Okay.
But, yeah, it's no big deal if you forget.
Okay.
Okay? Oh.